Kia ora koutou. This video is for my level 2 stats class and it's for trigonometry, and it's the first video that I'm making about the cosine rule. So the cosine rule is the second big new thing we've learned this year, and it helps us to find either an angle or a side in a non-right angled triangle. In this video, I'm going to look at how we find a missing length. So the first thing we're going to look at though is when we need to use the cosine rule, and I've got a little example done here already for us. The easiest thing to use when we start doing non-right angle trig is not the cosine rule, it's the sine rule. Okay, and we use the sine rule when we've got an angle and the opposite side. So here we've got 62 degrees and 50 centimeters opposite it. If we're looking for a side, we might call that x, and we've got the opposite angle, then we're good to go with the sine rule. So in this case, we can write the sine rule out as follows. A over sine of big A is equal to B over sine of big B. And that's the same as the third opposite pair in the triangle. So all we have to do is be careful with knowing where are my opposite pairs, and then we substitute into the formula. So just getting rid of some of the mess on this triangle, I'm just going to go over how we do the labeling because we hold on to that the whole way through this topic. Okay, so now we can see we've got rid of some of those dots, and now we've got rid of the triangle. That wasn't so good, was it? Okay, let's put the triangle back in. Close enough. So we label this one big A and this one little a. And then we label this angle here big B, and that x is little b. And off we go. Now, I'm not going to bother in this video to work through the sine rule calculations here because I think everyone's got pretty good at that. What I'm going to do is 3 examples of our new rule, which is the cosine rule. So we use the cosine rule when we don't have an opposite angle side pair. For example, in this one here, suppose that we've got 58 degrees here, 9 meters here, 7 meters here, and we want to figure out this length over here, which I'm going to call x. We've only got one angle, but we've got both of the sides around that angle. And that's your trigger to go looking at the cosine rule, right? So the problem is, just going over what the trouble is again, we've got this angle, but we don't have the opposite side. So we're a bit sad, right? Because we've got really good at the sine rule. But the cosine rule is the next thing that we go on to learning, and it's not too bad once you've done a few of them. The other thing to notice is that we don't have a second angle in here, right? And if we had a second angle, then we definitely would have an opposite angle side pair. So getting rid of all of the mess, what can we do? Well, the cosine rule is going to help us find a length as follows. We've got a squared is equal to b squared plus c squared minus 2 times b times c times cos of a. And you'll remember that when we're doing algebra, we don't need to write all those times signs in, so we'll just see it written on the formula sheet like this. But you guys are going to do so many examples in different contexts that you probably will know that formula off by heart. So just looking at it now, what we have to do is figure out what's a, b, and c, and what's my angle a. And as before, we've got a little a here and we've got a big A here for my opposite pair. So the side that we're looking for is the one that we're going to label little a, and the angle is big A. And then we can choose which one is the B and the C. It doesn't matter, right? So we'll call that one B and that one C. Right, now we're good to go with doing our calculations. So I'd like you to pause the video here and try and work through what comes next. And then I want you to watch it and make sure that your working is looking as clear as mine. Okay, so pause and give it a go. Right, so what we should have is this. Make sure your calculator's in degrees. So we have a squared. Now we're going to substitute in 7 squared plus 9 squared minus 2 times 9 times 7 times the cosine of 58 degrees. And when we work that through, that should give us 63.2302. So that's a squared. but we don't want a squared, right? Because what's a squared? Well, a squared geometrically, I'll try and draw it on here without making a humongous mess. A squared is a square with side length of that. So a squared is the area of that square formed off there. And you guys might remember doing some playing around with that when we first learned Pythagoras back in year 10, right? But we're not interested in a squared, we just want the side length. So to get to the side length from a squared, we're going to take the square root. Okay, so we're taking the square root. Sorry, OneNote just did a weird glitchy thing there. So the square root of 63.2302 will give us, let's see, what do we get? So I get x, which is the same as a. So x is equal to 7.95 metres. And I'd give that a big tick, right? That's a very accurate answer. But as I said in class, usually what I do when I'm at the very end of the problem is that I round my answer so that it's one significant figure more accurate than what I've been given. So here, 7.95 metres is fine, but 8.0 metres is also a nice way to answer that question. So that's the first one done. Okay, 2 more for you to try. Let's see. Okay, so I've got another triangle drawn here, and it's not to scale, and it's not to scale on purpose. In particular, it looks like it's got a right angle here, but there's no right angle box, right? So we're not going to assume that that angle there is a right angle. And we're not going to rely on our eyes for anything really in this problem. So we're going to assume that this angle here is 63 degrees. And we'll call this side here M. This side is 7 meters, and this side is 4 meters. Now, we take a look at it, and we can't use the sine rule because we've got an angle, but we don't have M, so it's not going to work. But we know we can use the cosine rule because I've got the angle, 63 degrees, and I've got the sides adjacent to it, or right next to it. So off we go with the cosine rule. So pause the video, work through this one, and see what you get. Okay, so for this one, I get a squared is equal to 7 squared plus 4 squared minus 2 times 7 times 4 times cos of 63 degrees. Make sure your calculator's in degrees. When I chug all of that through, I'll put one intermediate line in here. So 49 plus 16 minus 56 times cos of 63, if you want to do it that way. That gives me a squared is equal to 39.5765. So we don't want a squared, we just want a. And a is the same as length m. So m is equal to the square root of this, which gives me 6.29 or 6.3, what did I say for units? 6.3 meters. Okay, one more for you to try, and I've put just a slightly different example in here. I've done an isosceles triangle, right? So 42 degrees, 10 meters here, and we know that the sides are equal, so 10 meters over here. Right, I want you to do this using the cosine rule, and then I want you to look at it and work out how you can also do this one using the sine rule with just a little bit of extra thinking. So first, pause and do the cosine rule to find x, and then have a bit more think and see what else you could do with this triangle. Okay, so let's start with our labeling. I'll change pen color, I'm a bit sick of that one. So this is A, this is big A, this is little b, and this is little c. A squared is equal to b squared plus c squared minus 2bc cos A. Right, write out the formula and now substitute in. So it's equal to 10 squared plus 10 squared minus 2 times 10 times 10, which is 200, cos of 42 degrees. Now, when I chugged that through my calculator beforehand, I got a squared is equal to 51.371. As usual, we don't want the square, we want a. So a is length x, it's the square root of 51.371, which gives me 7.2 meters. Okay, but we've just got time to do that a different way. Right, so fine to do that using the cosine rule, and we got an answer of 7.2 meters, which looks about right. But now I'm going to get rid of all of that, and I want you to have a look and think about what we know from year 9 maths about isosceles triangles. So we know that the base angles are equal, right? So base angles isos triangle are equal. That means that this one and this one have got to add up to 138 degrees because angles in a triangle equal 180 degrees. 180 minus 42 is equal to 138. 138 divided by 2 is equal to 69 degrees. And that means that now we know that this angle is 69 degrees. So 69 degrees here and 10 meters here. So we're good to go with the sine rule. So just to show you that we get the same thing, I've worked this one through with the sine rule, and I'd like it if you did the same thing. Just get rid of our mess here. Hopefully we're going to get to 7.2 meters, right? So the sine rule for a side means we're going to have x here. So we're looking for side x here. And that goes with angle 42. So it'll be x over sine 42 degrees is equal to 10 meters over sine 69 degrees. X is equal to 10 times sine 42 degrees over sine 69 degrees, giving us in the numerator we have 6.691, and in the denominator we have 0.93358, and when we work that through on our calculator, we again get 7.2 meters. So there you go, 2 ways to do that question, the sine rule way or the cosine rule way. I think I actually prefer the cosine rule way in there, just because, I don't know, there's less trig to do on your calculator. But both of them are good, and you need to be really confident with both of those methods. The next video that I'm going to do is how we can use the cosine rule to find a missing angle. So thanks for watching, and email me if you're in my class and you've got any problems with the work out of the Walker book or any problems with this video.